In this lesson video for day 4.2, we're going to be talking about polygon similarity. Okay, we're going to talk about what it means for polygons to be similar. In the last lesson, we used ratios and proportion to solve problems. We are going to use the concept of proportions in similar polygons. So first, let's kind of clarify what it means for polygons to be similar. Polygons that are the same shape but different sizes. So let me fix that for you a little bit. Are considered similar polygons. Okay, polygons are similar if we can say two things. If, first of all corresponding angles are congruent, they're similar polygons. Okay, remember that symbol means congruent. Okay, and if all corresponding sides are proportional. All right, and so that is what makes polygons similar. If their corresponding angles are all congruent and their corresponding sides are proportional. So the ratio of the corresponding sides is called the scale factor. Okay, we did scale factor when we talked about dilations because we said that was a similarity transformation. We did dilations back in Unit 2. Okay, so scale factor is what we call that ratio of corresponding sides. If polygons are similar, then their perimeters are also proportional. Okay, the perimeters would also be proportional because the perimeter is just the sum of all the sides, and so that works out the same way. Okay, so let's first identify some scale factor problems. The scale factor is the ratio of the corresponding sides. Now, the order in which we compare these is very important. Okay, we want to match up corresponding sides, and we can do that by understanding the length measurements and how they correspond to the other length measurements and how they're related. So when it says what is the scale factor of a triangle DEF to ABC, we are needing to follow that order. That's big to little. Okay, you can tell triangle DEF is bigger than triangle ABC, so that is important for us to follow. So what I want to do is match up corresponding sides. Well, if I look at triangle DEF here, the largest side is the 27. That has to be the corresponding side to the other largest side in triangle ABC, which would be 18. Okay, or I could do smallest side to smallest side too. I could do 12 to 8 because those are smaller sides. All right, so I'm going to write either one of those. I'm going to pick the one I said originally. So I'm going to compare that as a ratio, 27 from the first triangle over 18 from the second, or I could write it as a ratio this way. But for most of these ratios today, we'll write them as fractions. Okay, and I want to reduce that. Now you should notice that you can divide by a couple different things. You could divide both of these by 3, but you could also divide both of them by 9. So if I divide by 9 first, that actually reduces this further for me. So 27 divided by 9 is 3, and 18 divided by 9 is 2. So the scale factor of triangle DEF to triangle ABC is 3 to 2. Okay, or I could write it as a colon, 3 to 2, like that. But then in part B, they ask, what is the scale factor of ABC to DEF? That's just flipping it around the other way. So instead of 3 to 2, it's 2 to 3. Again, I could pick the sides that correspond again, 18 over 27, or I could just use the same measurements I reduced them down to from the last problem. Then it says, what is the perimeter ratio, or the ratio of the perimeters of DEF to ABC? Now, you could find the actual ratios of the perimeter by finding the actual perimeters. And so we could add those up. 8 plus 10 plus 18. Well, that's 18 plus 18, which is 36. Okay. I don't know if you can see that, 36. All right. So the perimeter of ABC is 36, but I need to find the perimeter of DEF. So that would be 12 plus 15 plus 27. If I add those first two together, that's 27 plus 27, which is 54. So that's a perimeter of 54. So the ratio of the perimeter from DEF to ABC would be 54 over 36. And as you look at what we can divide by, you might recognize you can divide both of these by 2. We could sure do that first, 27 over 18. Well, hey, we just did that. We did 27 over 18, and that reduced to 3 over 2. So you'll notice that the perimeter ratio of DEF to ABC is equal to the individual scale factor of DEF to ABC. And you'll notice that is always the case. The ratio of the perimeters is going to be equal to the scale factor of the individual sides. Okay, so let's keep moving. So let's look at some examples. All right, so we've got our examples here. The polygon pairs that are listed are similar. We have to know that before we can apply any other information. Okay, because they're similar, I know corresponding angles are congruent and corresponding sides are proportional, and we can determine scale factor. So we're going to determine scale factor of B to A by using the ratio of corresponding parts. Remember that the order matters and you must simplify your answer. So we want to go from B to A. That is very important. B measurement to the A measurement. Okay, in this case, in example 1A, B, triangle B, is the smaller of the two, so we're going to go small to large, all right? And I want to compare corresponding sides. So I'm going to pick the smallest of these sides, 3 inches, and it corresponds to the smallest of the other sides. It just so happens that they're both on the bottom. Okay, so that would be a ratio of 3 to 12, and I can simplify that ratio by dividing both by 3. So my simplified scale factor is 1 to 4. I can write it as a ratio that way, or I can write it as a fraction. It doesn't really matter. Okay? On example 1B, however, the polygon B, or rectangle B, is the bigger of the two. So this will be a big to little ratio because we're still going B to A. Pay attention to the order. So I'm going to pick corresponding sides. Now you notice that 24 is the bigger side than 6. So if I wanted to compare the smaller side of that triangle, or not triangle, that rectangle, I would use side 6. And it has to correspond to side 4. Those have to go together. They're in matching places. They're both the smaller of the two dimensions. So 6 to 4 is that ratio. But we don't want to leave it there where we want to simplify or reduce. We can divide both of these by 2, giving me a simplified ratio of 3 to 2. And again, you could write that as a fraction, 3 over 2 as well. Okay, so that's how we can use scale factor when we know that triangles are in fact similar. Well, now we are going to look at something called similarity statements, which are very much like when we talked about congruence statements. And the key idea here is that order matters, okay? The order of these statements tell you which parts are supposed to go together when the markings and measurements aren't necessarily given, okay? So the similarity statement here, I'll highlight it for us. This similarity statement, triangle JKL, is similar to this symbol here is called a tilde symbol, and that means is similar to. So triangle JKL is similar to triangle PMN, and that order of those letters tells you which parts go together. So as I look at this, angle J corresponds to angle P. In similar polygons, corresponding angles are congruent. So I know angle J is congruent to angle P, so I can mark that and I can say angle J is congruent to angle P. And I also know angle K corresponds to angle M, so those are congruent. Angle K congruent to angle M. And finally, angles L and N are corresponding, so they're congruent. Angle L is congruent to angle N. Okay? But notice that my chart looks a little different here when I come to talk about the sides. I'm not going to have three separate statements for the side comparison. I'm going to have one long proportion, and we could call this an extended proportion because there are three pairs of corresponding sides. We know that corresponding sides are proportional. And since I started with triangle JKL on the left, I'm going to write my first ratio as a fraction where the measurement on top is coming from triangle JKL and the measurement on bottom is coming from the other one. So I'm going to start with one side. I'm going to use side JK first. That side must correspond to PM. That ratio, they're not equal. I'm not going to say they are congruent. I'm not going to mark them as congruent. But that ratio of JK to PM has to be equal to the ratio of all the other corresponding sides. So another pair of corresponding sides would be KL and MN. Since JK was on the top, KL must be on the top, and MN then has to be on the bottom. But there's a third pair of sides we can use. So I'm going to say equals another ratio. The third pair of sides would be JL and PN. Okay? And so that's how I would write the proportionality of the sides, or how I would write that the corresponding sides are proportional. So let's try another one, okay? And the picture can be helpful, but when we come to writing out, filling in these boxes like this, really this statement is the most important piece because it tells you which parts go together, and then it's just a matter of matching them up. So what I want you to do, I want you to pause the video here, and then I would like for you to fill these out as best you can, and then click play when you're ready, and you can check your work that way. If you are having any trouble, go ahead and click play and you can see what I've gotten. All right, this is what we should get. Okay, as you look at these, the corresponding angles would be angle X and angle R. So angle X is congruent to angle R. And then both triangles actually share angle Y. So of course, angle Y has to be congruent to angle Y. And then the other angles, Z and S, are congruent as well, okay? Okay, so as we look at this, the corresponding sides work out in this proportion. XY over RY must equal YZ over YS, and that must equal XZ over RS. Now, the individual fractions that you have written could be kind of flip-flopped around, but it really needs to have X, Y, and Z across the top row and R, Y, and S across the bottom row to keep with the order we were given from that similarity statement, okay? So we can use similarity figures to find missing measures. We can use similar figures to find missing measures. So we can set up a proportion and match the smallest part of the scale factor beside the smallest measurement of the figure, and then biggest beside biggest, okay? So we want to match them up in corresponding places. So if we are given that two triangles are similar, all right, and they have a scale factor of 4 to 5, you can also think of that as the 4/5 fractional version. That's going to be helpful. The smaller triangle has a perimeter of 72 centimeters. We can find the perimeter of the larger triangle. We don't even need the pictures to do this because remember, perimeter follows the same ratio as the scale factor. So I'm going to set up a proportion, all right? So I'm going to do 4/5 must equal the perimeter of the smaller triangle over the perimeter of the larger triangle. Well, the smaller triangle has a perimeter of 72, so it needs to go in the place of the smaller number from the scale factor. And then I'm looking for the larger perimeter. I'll call it P instead of X, just because we're finding perimeter. And then all I have to do is cross multiply. 4P equals 5 times 72. Let me get my calculator. And 5 times 72 is 360. And then all we have to do is divide by 4. And we get P is 90. So the perimeter of the larger triangle is 90 centimeters. And that's how you can use scale factor to help find missing measures. All right, let's keep going. Some more examples here. Another example like that. Given that two triangles are similar with a scale factor of 2 to 5, The larger triangle has a perimeter of 65 inches. Find the perimeter of the smaller triangle. All right, we're again going to set up that scale factor as a fraction, 2/5. And then the other side of our proportion is small perimeter over large perimeter. Well, this small perimeter is what I'm looking for. So that's where my variable goes this time. And the large perimeter they give me is 65. So we're going to cross multiply again. 5 times p is 5p. And 2 times 65 is 130. And then we need to divide by 5. And we get that the smaller perimeter then is 26 inches. Okay, so we will keep on moving through. In these next examples, I'm going to do 1 or 2 of them, but then I'm actually going to move on. And at the end of the video, I will show you what the answers should be for those ones that I don't cover, just so you can try them on your own and check your work. But we are going to do one like this. So number 6, it says if the figures are similar with a scale factor of 2 to 3, find the value of x. Okay, so again, we're going to do this the same way we just did our perimeter problems. So we want to set up a proportion. Okay, I'm going to set up this as my first proportion, or first ratio in the proportion, 2/3. That has to correspond to either 42 over x or x over 42. Well, how do you know which one goes where? The smaller value should match the smaller side. So since 42 is the smaller of these two figures, this is one of the few times we get to go off of looks, the 42 goes on the top and the x goes on the bottom. So I can cross multiply again. 2x equals 3 times 42 is 126. And if I divide by 2, I get that x must be the length 63. Okay. All right. So we're going to skip 7 and move on down to 8. We are told that these are similar, and the similarity statement is going to help me know what the order is, because this time I have to use my own scale factor. I have to find the scale factor first. And that just means I need to find a ratio of corresponding sides that works. Okay, so on the smaller or the bigger triangle, ABC, we have 2 measurements we can use, either the 20 or the 25. Let's say I was looking at the 25. That's AB. AB corresponds to DE. So this side, 25, goes with the side DE, X. Well, that's one side of a proportion. I could do 25 over X, but I need to set that equal to the scale factor. The scale factor is going to come from the other 2 sides. The other side given in the big triangle is BC, 20, and BC goes with EF, 28. Now I know 20 is the bigger one. Okay, these numbers don't actually match up. Okay, so I almost got confused there. But 20 goes with ABC, just like 25 went with ABC. And then 28 goes with the other triangles. Even though it looks smaller, we can't go off of looks this time. Don't get confused by that. But that's our scale factor. All right, because of the similarity statement, that is what we have to go with. So we can cross multiply now. 20x for one side, and then 700 for the other side. And then we divide by 20. And 700 divided by 20 is 35. So that's the missing value for that problem. All right, again, we're going to skip number 9. You would do that in a very similar fashion to number 8. We're going to go down to number 10. Okay, to try and keep these videos a little shorter, I'm going to skip around a little bit. So this time we're going to set up a proportion again, but we're going to have to do some algebra with that proportion. Now, what you need to be careful of, we're using similar polygons, which says that corresponding sides are proportional. So when we set up our proportion, I kind of go ahead and put a blank template up there for you. Fraction equals fraction. We want to match corresponding sides. Now, we have the most information about those sides up there. Okay, triangle ABC is the bigger one, and triangle ADE is the smaller one. So if I wanted to do the ABC values on top and the ADE values on bottom, that's fine, but you need to understand that we're going to compare a full side of triangle ABC to a full side of triangle ADE. So I'm not going to compare 8 to 20 or 20 to 8. I'm going to compare the full side of AB, which is 28, 20 plus 8, over the full side that it goes with, AD, 20. And if you don't make that comparison correctly, if you don't set that fraction up as 28 over 20, it's going to give you mistakes. Now, the full side that goes on the other side is this BC length, 2x plus 3, and it matches up to this full side, 15. And those are each a full side of the triangle. Okay? Now we can cross multiply and solve. Now you could do this straight as it's written, but if you wanted to reduce some of the numbers first, you could. We could simplify this fraction a little bit. 28 over 20, I can divide both of those by a common factor and make this a little easier to work with. I could divide both of these by 4. 28 divided by 4 is 7, and 20 divided by 4 is 5. Those numbers are a little easier to work with. You don't have to. You can use 28 and 20. It's just for the sake of making the numbers easier, that can be done. So when I cross multiply, I'm going to do 7 times 15 and 5 times 2x plus 3. Okay, 7 times 15 is 105. And that equals 5 times 2x plus 3. That quantity you can write like this. And then we need to distribute, like we learned in some of our proportion work in the last lesson. 5 times 2x is 10x. 5 times 3 is 15. Okay? And so I'm going to subtract the 15 from both sides. If I do minus 15 from 105, that's 90 equals 10x. Here, I'll show that work. And then I divide by 10. And we get x is 9. But they ask for the length BC. So to find that length BC, I'm going to plug 9 back in here. 2 times 9 plus 3. Multiply first, so 2 times 9 is 18. 18 plus 3 is 21. Okay? So that is my final answer, BC equals 21. All right, we're going to skip 11 also. You can set that up. I do want to point something out to you. The order here would be very important. The sides that go together would follow this proportion. So if you're going to try this one on your own, let me give you the labels that would go together. Okay. NP, if I started with that one, that's only one way to do this. If I start with NP, NP corresponds to RP, this side. So these kind of cross each other. That ratio must equal MP, which corresponds to QP. So we can fill in our numbers for this proportion, and that will help us solve that one if you're going to work on that problem. Okay, that actually finishes our examples for 4.2. So what I'm going to do is I'm going to show you what these answers should be for 7, 9, and 11. So if you want to try these, if you haven't yet, pause the video and then you can check your answers real quick. Otherwise, that concludes our lesson for day 4.2. On 7, you should get x is 33.6. On 9, you should get x is 60. And on 11, you should get x is 10. So NR is actually 39. You have to plug into both of these and then add your results to get the total for NR. Okay.